Question 5. In certain African countries, 4% of the newborn babies have sickle cell anemia, which is a recessive trait. Out of a random population of 1,000 newborn babies, how many would you expect for each of the 3 possible genotypes? So our population is 1,000, and we have 4% sickle cell, which is our recessive trait. Now, a common error is people will put 0.4 for 4%, but remember that it is 0.04. So our little a is 0.04, and that means our Q squared is also 0.04, and our Q is going to be 0.2. So if we use our P plus Q formula, where P plus Q equals 1, that means P must be equal to 0.8. Now that we've got these two numbers here, our Q value and our P value, we can solve for the rest of the problems. So for each of the 3 possible genotypes, so our big A is our P squared value. So P squared value is going to be 0.8 squared, and that means that we have 0.64 with a population of 1,000 times 0.64. That means we have 640 that are homozygous dominant. For our heterozygous, that is our 2PQ. So 2 times 0.8 times 0.2, and that is going to be equal to 0.32. So 1,000 times 0.32 is equal to 320 heterozygous. And finally, we have our homozygous recessive, which is our Q square value, and that is going to be 0.2 squared. And so our Q squared is 0.04, and actually we didn't even need to do that because we had it in the beginning. But let's roll with it. So if we take 1,000 times 0.04, we end up with 40 homozygous recessive individuals in this population. And so to double check, 640 plus 320 plus 40 should all add up to 1,000. In question 6, in a certain population, the dominant phenotype of a certain trait occurs 91% of the time. What is the frequency of the dominant allele? So here we're not dealing with the number of population. They just want to know what is the frequency of the dominant allele. So if you remember from the beginning when we were talking about what do we mean by a genotype and an allele, the allele is just the single letter. And so our dominant allele here is just the letter P. So really what we want to do is just find the P value for this particular question. So if our dominant phenotype, so our dominant phenotype is the big A, and the heterozygous, that is 91% or 0.91. That's too hard of a number to work with because really we're working here with our P squared and our 2PQ values. What's far easier to work with here is our Q value. So if we know that our dominant population is 91%, we know that our recessive population is going to be 9%, which means our Q square value is equal to 0.09. So if Q square, sorry, we zoomed out there. I had a phone call, that's why it zoomed out. If Q squared is 0.09, that means Q must be equal to 0.3. And so if P plus Q equals 1, that means my P value is 0.7. And that is my final answer because all they wanted to know was what is the frequency of the dominant allele. In question 7, 4 out of 10 people in a population were able to taste a harmless chemical. The ability to taste this chemical is a homozygous recessive trait. If you assume that the population is in Hardy-Weinberg equilibrium, what is the frequency of the recessive allele in the population? What percentage of this population is heterozygous for this trait? So here we got 4 out of 100 people in a population tasting the harmless chemical, and that is the ability to taste is a recessive trait. So we know that 4 out of 100 is our little a little a, our recessive trait. So 4 out of 100, if you do the math, is 0.04. And that means that is our Q-square value. So 0.04 is our Q-square value, then that means Q must be 0.2. And so in this question again, it says what is the frequency of the recessive allele? Not of a genotype, just the recessive allele. That is just asking us for Q, as the question above had just asked for P. In the second half of the question, what percentage of this population is heterozygous for this trait? So they're asking us for the 2pq value. Well, we don't have P yet, but we can figure it out real quickly. If P plus Q equals 1 and Q is 0.2, that means my P value must be 0.8. So with 2pq, that's going to be, sorry about that, that's going to be 2 times 0.2 times 0.8, which is 0.32. And so they are asking what percentage of this population, and my frequency is 0.32. That means my percentage is 32% heterozygous. And those are your two final answers.